All right, welcome back. So one of the things I've been doing very successfully in this channel is reading things out loud to the camera. I think that's a decent way to actually uh, become informed and to learn stuff, and then it kind of is a dual benefit, right? I get better at speaking, which is a really important professional skill. So so let's continue with the Juniper validated design. I just think this is the best way forward. I'd love to get certifications. I think certifications are really valuable. But like this is one thing I've been doing successfully so far. So let's continue it. All right, so the next part of a Juniper validated data center design, specifically for the use of AI, is the front end. So this is the front end overview. The front end in AI refers to the interface, tools, and methods through which users interact with the AI system, allowing them to initiate training or inference workloads and visualize the results. The front end for AI makes the system accessible and useful for end users without requiring an understanding of the underlying technical complexities. The front end functions include the user interface, known as the UI, application and tools that provide the ability to send and receive information to the system, such as instructions, commands, and status queries. These could be in the form of a shell CLI or a graphical based interface. Users can interact with the AI system for setting parameters for a model, inputting data, or interpreting results. The next front-end function is user experience, UX. Interaction mechanisms or workflows that allow users to reach a desired outcome with ease, including device onboarding, configuration management, task orchestration, etc. Sound familiar? The procedures by which the user defines the desired outcomes and passes the required data and parameters to reach that outcome are also part of the UX. Okay, so the next one is data visualization. Application and tools that allow users to visualize and easily understand the insights generated by AI models and workloads. And then the next one is management of AI systems. Tools required to access storage and processing components, to configure and monitor them, manage workflows, and perform any required maintenance tasks. This includes tools to build and run the AI models and provide efficient and convenient ways to define, train, and use AI models. Examples include TensorFlow, PyTorch, and Scikit. So there we go. We're hitting all the buzzwords. We're not even completely forging off into new territory. I've done a series on configuration management, on device onboarding. Device onboarding is something I've done. I started my career basically by doing device onboarding. So it's like, this is I feel really good about this. A front end fabric provides the connectivity infrastructure for users to reach the AI systems, including GPUs and storage devices, from the user interface applications and tools. GPU overview. The GPU cluster in AI refers to the infrastructure that performs the actual computations tasks for AI workflows. It's the part of the system where the data is processed in GPUs as the AI models execute for training and inference functions. Training refers to the AI model learning with the curated dataset and a deep learning framework so that the mode is ready and is trained to respond to queries. Inference refers to using the trained model to provide actionable outcomes from user inputs. The backend GPU functions include AI systems. All right, so now this is the backend. It's an alternative to the front end. So the first backend GPU function is AI systems, and this is specialized hardware like GPUs, graphical processing units, and TPUs, tensor processing units, that can perform several calculations simultaneously, speeding up the training and execution of AI models. GPU designs provide efficient execution of AI workloads, performing complex computations required for matrix multiplications, convolutions, etc., which are common in AI processing. AI software is another back-end GPU function. This includes the operating systems, libraries, and frameworks that are used to build and run the AI models. The next back-end GPU function is data management. This involves managing the data that is used to train and run AI models. It includes data storage, data pre-processing, such as cleaning and normalization, and data transformation, such as feature extraction. So there you have it. Data science stuff is not going anywhere. It's here to stay. It's really important going into AI. Trad networking, OSPF, perhaps not so much. Definitely not frame relay, although that is off the CCNA now, as far as I know. The backend needs to handle large amounts of data and complex computations efficiently. This often involves techniques like parallel processing, distributed computing, and hardware acceleration. Model management. This involves managing the AI models themselves. It includes model evaluation, such as cross-validation, model selection, choosing the best model based on performance metrics. And we remember, the different kinds of models based on when I read machine learning for network and cloud engineers. So there's convolutional neural networks, there's generative neural networks, there's even models that aren't neural networks. The k-means model is pretty archaic, but there are other models as well that are used in AI competitions to really good effect that aren't neural networks. The big one I actually can't remember. So let's see what that is. So, all right, so evaluate this claim. There are models used in AI competitions that aren't neural networks and that are leading to victories. Yeah.
Yes, there are models used in AI competitions that are neural networks and have achieved notable successes.
Yeah, XGBoost.
While neural networks, especially deep learning models, have been dominant in recent years, other types of models still play significant roles in various contexts. Here are some examples. 1. Decision trees and ensemble methods, gradient boosting machines, GBM, XGBoost, and LightGBM. These are powerful ensemble methods that combine multiple decision trees to improve predictive performance.
Yep.
They have been widely used in competitions like cattle, often outperforming neural networks, especially in tabular data scenarios.
Exactly.
Random forests, another ensemble method that combines multiple decision trees to enhance prediction accuracy and control overfitting. 2. Support vector machines, SVMs. SVMs are effective in high-dimensional spaces and are still used in competitions for tasks involving classification and regression, particularly when the number of dimensions is greater than the number of samples. 3. K-nearest neighbors, KNN. KNN is a simple instance-based learning algorithm that can perform well on certain types of problems, especially when the decision boundary is irregular. 4. Bayesian models, naive Bayes, particularly useful for text classification tasks due to its simplicity and effectiveness. Bayesian networks, these probabilistic graphical models can be effective in handling uncertainty and incorporating domain knowledge. 5. Linear models, linear regression and logistic regression. These models are foundational for many statistical learning tasks and can perform well in cases where the relationship between input features and the target variable is linear. 6. Evolutionary algorithms, genetic algorithms and other evolutionary strategies are used for optimization problems and have shown success in various competitive settings. Examples of success, cattle competitions. Many top-performing solutions in cattle competitions have utilized ensemble methods like XGBoost and LightGBM. These models are particularly effective on structured tabular data. ACM and IEE competitions, SVMs and decision trees have also been successful in specific machine learning challenges. Summary. While neural networks, particularly deep learning models, have gained a lot of attention for their performance in image, text, and speech tasks, other types of models still hold significant value in AI competitions. These non-neural network models often excel in specific domains, such as tabular data, where they can outperform neural networks due to their simplicity, interpretability, and efficiency. Thus, the claim that there are models used in AI competitions that are neural networks and that are leading to victories is accurate. The choice of model often depends on the nature of the problem and the type of data involved.
Yeah, so sorry, I was getting a glass of water. Sometimes I just kind of let these play sometimes because I'm listening. I'm on Bluetooth headphones. There's all kinds that aren't neural networks. So that's a big part of the back end is model management. It includes model evaluation, so like which model selection, choosing the best model, and that's not necessarily a neural network. And model deployment, making the model available for use in applications. The choice of GPU cluster systems can significantly impact the speed and efficiency of AI model training and inference. The backend GPU fabric provides the connectivity infrastructure for the GPU performing the AI tasks to communicate with other GPUs. Perfect. All right, so the next section is storage overview. The storage cluster, and they're going to use Weka storage in this case. That's what they recommend. The storage cluster in AI refers to the hardware and software infrastructure that is used to store, retrieve, and manage the data typically involved in AI workloads. This includes local high-performance storage devices storing large data sets for fast access to data during model training and inference. These devices have been designed and optimized to support the high input-output throughput required by AI tasks and to hold massive amounts of data. Because remember, it's all about the data. It's trained on massive amounts of data, so storage is a big part of it. The storage functions include AI systems, specialized hardware like GPUs, graphics processing units, and TPUs, tensor processing units, that can perform several calculations simultaneously, speeding up the training and execution of AI models. GPU designs provide efficient execution of AI workloads, performing complex computations required for matrix multiplications, convolutions, etc., which are common in AI processing. The backend storage fabric, including in this Juniper validated design, provides the connectivity infrastructure for storage devices to be accessible from GPU servers. Solution architecture. The three fabrics supporting the artificial intelligence Juniper validated design, AI JVD design, front end, backend GPU, and backend storage interconnect together in the overall AI JVD solution architecture as shown in figure 2. So we have the three components, right? We have the front end, we have four components. We have the front end, the back end, the GPU, and the storage. It looks like see, and now we're getting into the good stuff, right? So now we're getting in. So first thing I think to notice is the NVIDIA H100s, because these are the things that are, in contention right now, right? Like if we don't get these, if something happens with our chip production or something, that's going to cause problems with progress. Although there is a case to be made that, due to the multifaceted growth of the technology, progress made in other areas can make up for that. And then, another chip like an A100, even though the training runs will be slower, months instead of days, you can still get the training runs done, and that's really all that matters in the end, is calculating those weights, how fast you do it, as long as you can do it in a timely way. Doesn't really matter that much in the end. But so there are people buying these up and just holding them to sell them later. We saw on Amazon it's about $30,000 a pop for a H100, but you can do training runs in days. Where with the A100, which was a pretty penny itself, would take months, and then anything beyond that, you're dead in the water. Really, when NVIDIA is what it's all about. Yeah, so an NVIDIA H100, $30 a pop, 30,000 a pop. And an NVIDIA A100, about a third of that price, depending. So this is 2/3 of that price, but yeah, it looks. Oh man, this would be awesome. Oh. A desktop PC that is probably certainly costs a lot more than my car. I'm not a car guy, so I just have the most reliable, most affordable car I could get. But yeah. So okay. So let's see how that fits in. So we've got four of these H100s, and then we've got a super micro A100 times four GPU servers, and then we've got Weka storage servers. We got eight of those in this validated design. So now we've got out of band management. We're using Juniper Apstra for that. So I think that's like a what was it? It was called like Cisco uh, uh, DNA Center. Yeah. So I think it's like an alternative to Cisco DNA Center, basically. But there's different buzzwords that mean it does like different things in different ways. So Juniper Apstra is intent based networking, and it automates and validates the design, deployment, and operation of data center networks from day zero through day 2+. All right, so going back to here, what would be really cool is if you could build your own home AI data center using like RTXs, and like you can train in like 3 to 6 months. You just leave that thing burning, and like you can train a like one of the most sophisticated. You can be in like the top 1% of home trained private AIs. Because you could, I mean, for $10,000 for an RTX. Yeah, RTXs are like $300. The one I have, an RTX 2060, which is probably pretty old by now. Yeah, they're up to a 4060. They're up to a 4090. I mean, that's 300. That's nothing. Yeah, this 4090, which is the absolute, cutting edge. Like you can play any game in ultra settings in VR on a Pimax under 2000. That's pretty good. So like yeah, if you could maybe you could use something like Apstra, and just buy a bunch of even the one I have, like the 2060. That's going for 200 now. So like buy 10 of them for 2000. Buy some switches or something to, or you'd have to get like motherboards, right, to plug them in, or like a GPU a blade server. Yeah, so you can get a GPU blade server for another 2000. Or you don't even need like a blade server, right? You can get a just a motherboard that supports the connection and that is like high speed, right? So you could do it in like a desktop tower or anything. You could build a really powerful home AI rig, or just for a business too. If you want a private AI, like you for $10,000, I think you get something pretty awesome. All right, so yep, so we've got the GPU backend spine. So remember that this is the backend GPU fabric. Now we've got 400 gigabit Ethernet, and it's Ethernet too. I think that's what the E stands for, which is surprising that they recommend Ethernet and not InfiniBand. I hope they say more about that later. But yeah, then it connects to the STRIPES, the stripes. I don't know what that means. And these are GPU backend leaf switches. So this is all part of the backend GPU fabric. And they connect at 200/400. Wow, really fast speeds. I'm surprised there's an E there because I think it's InfiniBand. And they connect to GPU server. So that's different than a GPU backend spine. it's a GPU server. Okay, and then we've got server 1, 2, 3, and then as many as you could possibly want. And then those connect into the backend storage fabric. They connect at slower speeds, 100/200. They connect to storage backend GPU leaf devices, and those connect to through port channels, through multi-chassis port channels. They connect to storage backend spine devices. All right, but that's not all. The GPU servers, they kind of serve as in between the backend storage and the backend GPU. We can see they're neither firmly in one or the other square. They're in between the two, and then they also have a connection to the front end fabric here. So we've got a front end GPU leaf. Then we have a front end spine, massive connections again, 2x in a port channel. And then they connect to head end SVR, Weka management servers, Weka 1, 2, 3. So these are the actual storage here. These are 8 of them. So we got 3, 4, 5, 6, 7. 8 of them right there. All right, so that looks good. Backend storage fabric is there, front end fabric, GPU fabric, and there was one more fabric, right? There was the GPU fabric, front end, back end, GPU, and back end storage. Yeah, so back end I guess they're missing a. Oh no, here's the back end storage. Here's the back end GPU. Here's the front end. Yeah, so there's only 3. All right, so next we're going to learn more about the front end fabric. I'm kind of losing steam here, so I feel like getting 2 pages done in a 64 page document is pretty good progress. So that's going to be it for this video. I'm happy to be reading this. I think this is very relevant to the AI boom. So that I think I'm going to be focusing on this and the NVIDIA cert going forward. So thanks for watching, and see you in the next one.